This time we're going to look at a phenomenon where the same integral pops up again in our calculations, and it's called recurring integrals, which we can solve just using basic algebra when we get to that point. So suppose we're trying to integrate e to the 2x times cosine 5x. We can apply our integration by parts, letting u equal e to the 2x and dv equal to cosine 5x dx. We get du, using the chain rule, is 2 times e to the 2x dx, and v is the antiderivative of cosine 5x, which is sine 5x over 5. Plugging this into our formula, we get the integral of e to the 2x is cosine e to the 2x times cosine 5x dx is u times v, which is e to the 2x times sine 5x over 5 minus the integral of v du, which is the integral of sine 5x over 5 times 2 times e to the 2x dx. And now tidying up a little bit, we get our integral is e to the 2x times sine 5x over 5 minus 2 over 5 times the integral of e to the 2x times sine 5x dx. Now we've highlighted this last integral, the integral of e to the 2x times sine 5x dx in brown, and it doesn't look any simpler than what we started with. Let's persist and use integration by parts again to try to solve this. Taking this integral in brown and making a substitution, let u equal e to the 2x and dv is sine 5x dx. And again we get du is 2 times e to the 2x, and v is the antiderivative of sine 5x, which is minus cosine 5x over 5. Plugging this into our formula, we get the integral of e to the 2x sine 5x dx is minus e to the 2x times cosine 5x over 5, that's u times v, minus the integral of v du, which is the integral of minus cosine 5x over 5 times 2 times e to the 2x dx. Now, going back and substituting this into our original integral, we get the integral of e to the 2x times cosine 5x equals an expression in exponentials and signs plus 2 over 5 times the integral of e to the 2x times cosine 5x dx. So our integral pops up again, and it looks like we're going around in circles. So let's tidy this up a little bit, and we get that our integral is equal to e to the 2x times sine 5x over 5 plus 2 over 25 e to the 2x times cosine 5x minus 4 over 25 times the same integral again. And actually this is quite easy to solve. This is just basic algebra from your elementary algebra classes. Our unknown here is the integral e to the 2x times cosine 5x dx. So let's call that unknown I, and we're searching for the value of I. So on the left hand side we have I, and on the right hand side we have a reasonably complicated function in x minus 4 over 25 times I. So to solve for I, we do what we did in basic algebra. We bring all of the terms with I in them to the left and all of the other terms to the right, and then hopefully we can isolate I and solve for I. So doing that, on the left we get 1 plus 4 over 25 times I equals this reasonably complicated looking function in x, but nevertheless it's an explicit function of x. And on the left hand side we have 29 over 25 times I equals this function of x on the right. and now multiplying across by 25 over 29, we get a value for I, which was our integral. It's equal to 25 over 29 times this function in brackets, which is e to the 2x times sine 5x over 5 plus 2 over 25 e to the 2x times cosine 5x. So the method here is that you persist in using integration by parts until your original integral pops up again on the right-hand side, and then you simply use algebra to solve for your original integral.